This is the video for solving quadratic equations. At the end of this lesson, you will be able to solve for the given variable in a quadratic equation. You will do this by continuing to factor completely. So let's take a look at the warm-up at the top of our page and answer each of these questions. If a times b equals 0, then what do you know about a or b? So a and b are variables. We don't know what they are, but if we multiply them together and it equals 0, do you know what we know about what a must be or what 0 has to be? Or sorry, what b has to be? If you guessed 0, then you are correct. A or b must be 0. Or they could both really be 0 as well. Then that would give us a product of 0. What is the difference between an expression and an equation? Do you know the difference between an expression and an equation? If you were thinking that an equation has an equal sign while an expression does not, you are correct. The last part, number 3, asks, what is the standard form for a quadratic expression? So we've really been solving quadratics when we've been working with the AC method for the most part. So standard form, remember, is ax squared plus bx plus c. Today, we are going to work with quadratic equations. So what we're going to do is take the quadratic expression a x squared plus bx plus c, and we will be setting them equal to 0. So this is the equation, and above we have the expression. So let's take a look down below. Today we are solving quadratic equations, which means we are going to figure out what x equals in this equation. We're going to be solving these different than equations we solved in the past because I can see here that this is a quadratic, meaning that the highest exponent is a 2. So I'm going to follow the steps over here to the left. 1. Get the equation into standard form, which means we are going to set it equal to 0. Notice in this example, the equation equals -5. I want to bring the -5 to the left-hand side, so that way the equation is now equal to 0. And if I add 5 on the right-hand side, I must also add it on the left. In this case, I'm going to add 5 to the 19 because these are both constants. These are like terms. And now we have x squared minus 11x plus 24. So step 1, now it is in standard form. The quadratic expression is set equal to 0. Now when we're working on each of these quadratics, we are always going to factor completely. Remember that this means to factor until you can't anymore. So let's ask ourselves when we look here, is there a GCF? In this case, the answer is no. Is this dots? Can we factor this using the dots method? No, because it's a trinomial. So that means we are going to use the AC method. Let's list the factors of 24. And now we have to find which combination can get us to -11 when we add them up. I know that this gives me +11. So to get -11 means that both of these must be negative. Now, they still, in fact, do multiply to positive 24x squared, so I'm on the right track. Let's expand our middle term. X squared minus 3x minus 8x plus 24. And I'm going to make sure that since it is an equation above, that I keep it an equation the whole way through. I'm still factoring completely using the AC method, so let's group them. And now it's time to do GCF. Take out an x minus 3. Let's force the parentheses to be the same. And what number times x is -8x? In this case, it's -8. -8 times -3 is positive 24. keep it an equation the whole way through. I take my x minus 8, and they become one of the factors, and x minus 3 is the other one. Since I can no longer factor, x minus 8 is not factorable anymore, and neither is x minus 3. I am done with step 2. Step 3 says to make a t-chart and set each variable factor equal to 0, which means we're really saying that something or some number times a number is 0. Do you remember what we said before in the warm-up up above? If we did something times something and the product is 0, well then either A is 0 or B is 0. Which means in this case, x minus 8 is either equal to 0 or x minus 3 is equal to 0. So to help me out, I'm going to make a t-chart. And I will set this first factor here, x minus 8, equal to 0, just like it tells me to up here. And I will set x minus 3 equal to 0 as well. Solve and list your solution or solutions in a solution set. So I'm going to solve this equation here by adding 8 on both sides. So x equals 8. And over here, to get x alone, I will add 3 to both sides. So x is equal to 3. Which means that there are 2 answers to this equation that we were given originally at the top here in example 1. So I'm going to take both of my answers and list them in a solution set, which just means I'm going to use my curly brackets. Remember, we do from least to greatest. Number 5 says to check by substitution. So please have your calculators out and turn them on. I'm now going to check to make sure that 8 is a solution and 3 is a solution. So check by substitution, which means I'm going to take this here and see if I plug in 3 where I see x, will I really get this expression equal to negative 5? So let's test this out. I'm going to make sure I always plug in my number in parentheses. So 3 for my x squared. Okay, remember your calculator will look a little bit different. Then minus 11 times 3 in parentheses, and plus 19. And you can see that we are correct. It does equal negative 5. If we do the same thing and plug in 8 wherever we see x, we should also get negative 5 in the end. So let's check this out as well. And there you have it. It does equal negative 5. So we can say that we checked 3 can be a value of x, and so can 8. You're going to notice that for the most part, when we are solving quadratics, that we will typically get 2 solutions. Let's try another one. Example 2 on the back, solve the following quadratic equations. Remember that our first step is to get the equation into standard form, or just think of it needs to be set equal to 0. When I look at this one, do you notice how it already equals 0? So we don't have to take that step into consideration. Step 2 says to factor completely. Remember to ask yourself, is there a GCF? In this case, the answer is yes, the GCF is 7. 7 times r squared would give me 7r squared minus 2r plus 1. So we just did GCF, and let's see if we can factor again. I see a trinomial here, so that must mean I can do the AC method. So I'm not done factoring just yet. We get 1r squared. Now this is interesting because the only factors of 1 are 1 and 1. So let's think of a way how we can alter 1 and 1 to add up to a negative 2. In this case, they'll both have to be negative. And let's split up this r squared so they both become r. Let's replace our middle term. Remember, we're just going to ignore this 7 until the end. And now we have r squared minus 1r minus 1r plus 1 equals 0. It's time to group the first two and the second two and do GCF. Here the GCF is r and r minus 1. Over here, let's do a little forcing of the parentheses to be the same. So what times r is negative 1? Negative 1. And is negative 1 times negative 1 positive 1? So we are good to go. Let's continue writing equals 0. I'm going to take my terms outside the parentheses, so r minus 1, and then the inside parentheses r minus 1. Don't forget to bring down this 7 from earlier. So here we have just factored completely. Look back at your steps on the front. Step 3 says to make a t-chart and set each variable factor equal to 0. Which means in this case, I really have 3 factors, 7, r minus 1, and r minus 1. I know that 7 times something, if that has to equal 0, well then this means that either r minus 1 equals 0, or r minus 1 over here equals 0. I'm going to ignore this 7 because I know 7 can't be 0. 7 is 7. And let's solve. So r equals 1. And notice these two are identical, so we get r equals 1 again. In this case, we did get 2 solutions, like I mentioned before, but since they're both the same, we technically only have 1 solution, and we will put it in curly brackets. Please pause the video, take a moment, and in your calculator, please input 1 everywhere you see r, and see, do you get this expression, in this case, equal to 0. Go ahead. Alright, the last one here, number 3. Remember, our steps told us that we first must set our quadratic equal to 0. In this case, it equals 2d. Well, to get it to equal to 0, I'm going to minus 2d from both sides. This time, I will subtract 2d from 7d, since they are like terms. And now we have 2d squared minus 5d minus 12. Once it's equal to 0, we must factor completely. Is there a GCF here? In this case, no, so that means we are going to do AC. So negative 24 d squared, and let's continue listing our factors. We've been coming across 24 quite a bit, so hopefully you're getting good at listing the factors here. Which combination can we combine in some way to get to this middle term, negative 5? If you are choosing 3 and 8, you are correct, except we must make the 8 negative. Now they really add up to negative 5 and truly multiplies to negative 24. We must take the d squared and give it to both of our terms here. Let's replace the middle term with our 2 new chosen factors. 2d squared plus 3d minus 8d minus 12. Bring down the equals 0. It's time to do our mini GCF problems. The first one, the GCF is d. Let's make our second parenthesis and see if this works out. So what times 2d is negative 8d minus 4. And negative 4 times 3 is negative 12. So we are on the right track. Now we have our 2 factors, d minus 4 and 2d plus 3. Okay, remember we're solving now, so we have it equal to 0. And our steps tell us after we factor completely, we make a t-chart and set each variable factor equal to 0. So I have 2 factors here, t-chart, and set them equal to 0. So go ahead, set them equal to 0, and solve for d, keeping in mind that you will get 2 different solutions. So let's see. Notice I don't use the parentheses when I set equal to 0. So on the left, we get d equals 4. And on the right, let's see, divide by 2. Notice we get a fraction here. There's no need to change this to a decimal unless you are more comfortable with that, but d is by itself and it equals negative 3 over 2. So here are my two solutions. Negative 3 over 2 and positive 4. And that is how you solve quadratic equations. So we will continue tomorrow following our steps where we set it equal to 0, we factor all the way, we make a t-chart and solve for our variable factors. We solve each little equation and list them in a solution set. And lastly, we use our calculators to double check both of our answers. Please jot down any questions or comments that you may have for the beginning of class tomorrow. Thank you.